geometric series, the geometric series test for convergence. So a geometric series, we'll see like multiplication happening between each term, and it's going to be that same amount of multiplication. So for instance, if we look at these series over here, you see we have 2 plus 6 plus 18 plus 54, and we see that we multiply by 3 each time to get to the next term. Now, right below this, we have 64 plus 32 plus 16 plus 8, and we're multiplying by 1/2. So those values that we're multiplying by, is called the common ratio in a geometric series. That common ratio is going to be represented by R. That's that number that we're always multiplying by to get to the next term. Now, typically in our geometric series test, we have this coefficient, which sometimes is the first term. Sometimes the way the equation is written, it's not always the first term, but we're going to often represent A sub something, but typically A1 is going to be our first term of any series, but the first term is going to be important for us today. Now, a condition for convergence of a geometric series test is the absolute value of the ratio being less than 1, our series is going to converge. The absolute value of the ratio being greater than or equal to 1, the series is going to diverge. Now, what's kind of interesting about this is it's basically the opposite that we saw from the p-series test, so we do have to be careful with these rules, but just keep that in mind. Now, the other thing that's kind of fun about a geometric series is if it does converge, we can actually find its sum. Its sum is going to be equal to the first term divided by 1 minus the common ratio. So we'll take a look, keeping in mind also as you're working through these, geometric series can be raised to the n minus 1, they can be raised to the n. Typically, we're seeing that nth exponent that kind of signifies that we're dealing with a geometric series. All right, so when we take a look at our examples here, if the series converges, I'm going to ask you guys to find the sum also to get that practice in. If the series diverges, it diverges. There is no sum. It's infinite. We could continue on. So when we're dealing with the series, a lot of times it's not actually written in the exact form that we need it to be. So for instance, this one here, we have 3 over 4 to the n. Now, we can rewrite this as 3 times 1 over 4 to the n. But even more importantly, we're still not quite at that geometric recognition. We could rewrite this as 3 times 1 over 4 to the n. So I'm allowed to raise that 1 to the n because 1 to any exponent is still just 1. So what that does for us is it helps us identify our common ratio. Our common ratio is going to be 1 over 4, 1/4, which means the absolute value of our common ratio is less than 1, which makes this a convergent infinite series. Now, as I said, since we have a convergent infinite series, I'm going to ask you guys to find the sum. So in order to find the sum, we find the first term. Now we find that first term by taking whatever number is down here, so n equals 0, and substituting it into the equation. So if we substitute a 0 into the equation, I have 1/4 to the 0, which is 1, times 3. So my first term is 3, divided by 1 minus my common ratio. Now, as we kind of simplify this, we do the math out. We have 3 divided by 3/4, which when we flip and we multiply, we find out the sum is equal to 4. All right, so similar with this next problem here, where we have things being raised to the nth power, but we don't kind of see that one ratio being raised to the nth power. So we want to try and rearrange this formula if we can. So in our case here, we're going from 2 to infinity. That 3 to the n plus 1, what we can actually do is we can rewrite as 3 to the n times 3 to the 1, because when we add exponents, it's the same as multiplying the bases over 4 to the n. And then the cool part about this is we can group that 3 to the n over 4 to the n together. We can have that ratio of 3 over 4 to the nth power, and then that 3 we could just put up front. So again, what that allows us to do is find our common ratio. And since our common ratio is equal to 3/4, and the absolute value of 3/4 is less than 1, we again have a convergent series. So we could find our sum. Now this time, for the sum, if you notice the n at the bottom of our sigma is 2, so we have to substitute a 2 in to this equation to find the first term. So my first term, my a1 in this case, is going to be 3 times 3 over 4 to the second power, which our first term is going to be 3 times 9/16, or 27/16. Now we still have to divide that by 1 minus our common ratio, which is 3/4. So as we simplify this one just kind of had a little extra in there. We're going to flip and multiply by this 1/4, and we end up with that our sum is equal to 27/4. So a couple things you can do with those geometric series. Again, if they converge, let's find the sum. If they diverge, they diverge.